Hey guys, welcome back to Maths Recovery with Rebecca. So today we are going to be looking at the solutions for the trig equations with factorizing, the 4 that I left you to do on your own. Okay, let's start with the first one. So determine the general solution of the square root of 2 sin x cos x cos x. Now, it's very important to know that we are not allowed to divide both sides by cos x. Okay. Now, I know that I showed you before that dividing by cos x, let's just change this color to a dark blue. Dividing by the cos x is going to allow us to get a tan. But it's different over here, because if I go and divide by cos x, what's going to happen is this side going to change to a 1, and this PC over here is going to change to a tan x, but then you still have that cos x equals to 1, and that is not one ratio. Another thing is, a lot of you are going to be like, okay, what if I decide to let that, okay, let's just rub this all out so I can show you another thing that people going to think that they're clever doing. What if I decide and just cancel? So that just becomes the square root of 2 sin x is equal to 1. Like, doesn't that remove the problem, the fact that now we only have one solution, one ratio? No, that doesn't. What you've just done is you've removed a whole solution. You've removed the cos x solution in your equation, which means you are going to lose out on marks. Okay, so now how do I approach this? Because I'm not seeing squares. So you're going to think to yourself, well, if I'm not seeing squares, I can't take out a common factor, and that is where you are wrong. Let's move everything over, and what you'll see is the cos x is now your common factor. So we can take the cos x out, and I'm left with square root of 2x minus 1. Divide, see there? Divide it up across the terms. Let's go find our reference angle there. Remember, it has to be between -1 and 1 for it to actually be a real number. So that's fine. So the reference angle, so it exists. The reference angle there is going to be 90. This becomes sin x is equal to 1. Oh, I've already moved it over. Didn't even see that. 1 over square root 2. There's no need for us to go and rationalize that. All we need to do now is just find the reference angle. Then your reference angle here is going to be 45. And then we'll just look at what quadrants we're in. Well, 0 is positive, so we're going to be in quadrant 1. So that's just going to be x is equal to 90 plus k times 360, because it's cos, this period is 360. Or we're going to be in quadrant 4, because it's cos. So x is going to be 360 minus 90, which is 270 plus k times 360 k's. Let's look at this other side. It's a beautiful straight line. Where is sine positive? Sine is positive in quadrant 1. So that's just going to be x is equal to 45 plus k times 360, because that's its period. Remember, it might be easier for you, because I know I'm writing as fast as I can, but if I'm not going fast enough, you can speed this video up, which will make your life much easier, especially if you can see that you're getting it correct. And then you just check your solutions. Quadrant 2 is 180 minus. Great, let's look at the next one. Determine the general solution of this. Well, what I'm seeing is I'm seeing a square right there. So I'm just going to move everything over to the one side, because what I am picking up is a quadratic. k sine theta minus 1 to sine theta plus 1. Break it up over the times. I'm just going to solve for them in the same breath, which just makes my life easier. All of these are valid because they are between 1 and minus 1 or 1 and minus 1. Reference angle here is going to be 90, and the reference angle here, remember we're going to use the positive half. The negative is just going to tell us that we are going to be in quadrants 3 and 4. So here we're going to be in quadrant 1. So theta is equal to 90 plus k times 360. K is an element of integers. Or we're going to be in quadrant 2, which is 180 minus 90, which is 90 again. So I don't need to write it twice. Great. I'm only going to write it once. On the other side, yeah, negative quadrants. So it's going to be quadrant 3. 180 plus is 210. Or quadrant 4, 360 minus is just 330 plus k times 360 k's. Great stuff. Next one. Okay, interesting situation here. If I were dealing with algebraic fractions, I would just find an LCD. And because it's an equation, once I find my LCD, I can drop the denominator. Let's just take a look here. So my LCD is going to be 6 cos x. Great stuff. This one's over 1, so this one needs 6 cos. That's what that's going to become. This one just needs 6. This one needs just a cos x. And you see what that has become? Nice quadratic equation. And once I put it in standard form, let's see what happens. Can't divide anything. It's a minus 6. Great. So it becomes 2 cos x minus 3 and 3 cos x plus 2. Great. So we've got cos x is equal to 3 over 2, or cos x is equal to negative 2 over 3. Well, 3 over 2, remember if we look at our function of cos, highest is 1, lowest is minus 1, so this is no solution because it goes out of our interval. That's 1.5. This 2 over 3 is fine, so let's go find our reference angle here. Inverse cos 2 over 3, not negative. The negative is going to tell us which quadrants we're going to be in. This is 48,19 degrees. So because it's negative, we're going to be in quadrant 2 and 3. So x is equal to 48,1. Oops. It is 180. Sorry. 180 minus 131, yes, 131, 81 plus k times 360, or it's negative, so it's quadrant 3, which is 180 plus 48,19, 228,19 plus k times 360. Great stuff. Okay, let's look at the last one. Hopefully you're getting them all right. Okay, determine the general solution of that if that is true. Okay, So we've got, this reminds me a lot of those questions that come up in question 1, where they ask you, they say something like, determine, I think it's determine the solution of x squared plus 1 over x squared if, and then they give you like this basic one if they say this is equal to 1. These are very common questions that come up in question 1 for grade 11. I think they've come up quite a few times for matric as well, but it's a little bit more advanced algebra. And how we go about these is we take the one that has got the no expression, so no like square or whatever, so these ones have the squares, and we square both sides. But remember, when we square both sides, this now becomes a double bracket that we now have to FOIL. So that's what we're going to do on this side. So we can't go and square root this whole equation. That's not going to work because it's not difference of two squares. It's also, you can't break a square root up across a plus. So that's not going to work. So that's where this trap comes in. But what we can do is we can square both sides here. And this becomes tan theta. We'd have to double this bracket, and that's where they catch you out, because a lot of you are just going to let that square in, and then it's classified as a breakdown. Remember, these are over 1, so when we FOIL, this becomes x over x, which is just 1, another x over x, which is just 1, and then a 1 over x squared. So this, you see, let me get a highlighter here. I'm not going to rewrite it because, I mean, that one and that one, if you look at what the thing is, it just became 1. And then I've got 1 plus 1 plus 1, which is just 3. Very basic. And then I'm just going to arc it. Inverse tan. Remember, tan is infinite, so it can have a y value that is greater. So the reference angle here is 71,57, and then let's look. So it's positive, so we're in quadrant 1. 71,57 plus k times tan repeats itself every 180. So the solutions happen every 180. Or we're going to be in quadrant 3. Oops. That's 180 plus 251,57 plus k times 180, because tan repeats itself every 180. So hopefully you got this one correct. I actually enjoyed that. That was quite a challenge. Problem is, I've done so many past papers that I recognized it straight away. So maybe that should be something that you do before you write your November exam, or even now your June exam. Just go through the past papers. They are phenomenal. Anyway, have a good one. I hope you enjoyed my video. Please like and share and comment. Guys, I need you to tell me what you need. I'll be starting a Euclidean geometry channel soon as well. So that might be helpful for those of you that struggle there. But yeah, so I'm going to be building some trig, I'm going to be building some Euclidean geometry coming up soon. But please, in the comments below, tell me what you need. Even post some questions that you're stuck on, so that I can maybe post a short video on those difficult ones that everyone is stuck on. Yeah, have a good one.